Yo, Coach Ray here to teach you about sum and difference of perfect cubes. How exciting. Let's start with the title, sum and difference. That means it can be either. Okay, so we just did difference of perfect squares. It had to be subtraction. With perfect cubes, it can be either. Okay, so if you look at the examples, example 1 is subtraction, example 2 is addition. No problem. Okay, I want to kind of ignore all this stuff in the beginning here and just start with example 1 and then kind of come back up. All right, the first thing that I'm going to do is, because we have our a and our b again here, a cubed plus or minus b cubed here. Okay, plus or minus just meaning it can be plus or minus. Okay, I want to start by figuring out what's being cubed and what's being cubed. All right, cubed meaning that it's something times itself 3 times. All right, so the smallest perfect cube is 1, because 1 times 1 times 1 is 1. All right, what is the next smallest biggest cube? Or sorry, what is the next smallest perfect cube?
2.
No, there's nothing times itself 3 times it equals 6. There's nothing times itself 3 times it equals 9. No, we haven't even guessed 1 correctly. This is getting embarrassing. It's on video on YouTube. The next smallest perfect cube is 8. Okay, so listen to this. H. 2 times 2 times 2. So do 2 times 2, that gets you 4. Multiply your third 2, that gets you to 8. Next smallest one is 27. 3 times 3 is 9. 9 times the third 3 is 27. Next smallest one I think is 64. Then 125, and then I don't really know after that. All right, so we're going to start with this. We're going to start with figuring out what's being cubed, and in this case minus what's being cubed. All right, so my first one, to get 8, that's 2 cubed. 2 times 2 times 2 is 8. To get x cubed, that's just x. If you cube x, you get x cubed. Okay, for 27, that is a 3. Okay, 3 times 3 times 3 is 27. All right, I now know a, I now know b. I just did the hardest part, figuring out what's being cubed and what's being cubed. Okay, now we need the formula. Okay, the formula is key. I will give this to you. Do not have to memorize it. All right, this is how you factor perfect cubes. All right, they always factor to be a binomial times a trinomial. Notice I didn't write any signs in here. I just got a blank b, a squared blank. That's because I do the signs last. Okay, but right now I know it's going to be a binomial. I know it's going to be a trinomial, so I'm going to just start by writing those in. Okay, so I've got a binomial times a bigger one, a trinomial. All right, now I'm just ready to start filling stuff in. In my binomial up front, I just plug in a and b. Well, I just figured out what a and b is. That's just what's being cubed and what's being cubed. So I've got 2x here. I've got 3 here. That's just a and b. Okay, to go in the front of my trinomial, I take whatever a is and I square it. All right, a is 2x. If I were to square it, I got to square both of them. 2 squared is 4. X squared is x squared. So here I got 4x squared. I'm going to skip right to the back. The back is b squared. Okay, b squared is whatever this is that was being cubed. So that's 3. And if I square that, I get 9. Okay, the middle term. I find that, and it shows you up here in the formula. The middle term I find by just doing a times b. So 2x times 3 is 6x. Okay, I filled in all my stuff. Last thing is the signs. All right, my signs come from the acronym SOAP. If you remember the acronym SOAP, you will memorize how to do your signs. Okay, stands for same, opposite, always positive. So start at the beginning. I've got my binomial up here. The first sign is the same as the problem. And in this problem it was a minus, so the first sign is the same as the problem. Second sign is the opposite of the problem, so in this case it would be plus. Third sign is always positive. And now I'm done. I just factored a difference of perfect cubes. All right. Example 2. Okay, same thing. I need to start, and this is as hard as it gets. Again, I can't really make it harder than this. Okay, I need to start by figuring out what's being cubed, and in this case it's plus what's being cubed. All right, that'll be my a and b. To get 64, that's actually 4. 4 times 4 is 16. 16 times your third 4 gets you 64. So we start with a 4. All right, something times something equals x to the 9th, all times itself. So I'm just trying to create a situation where I have 9 total x's. What goes in each blank?
3.
X cubed. Okay, if I did x cubed times x cubed times x cubed, and I expanded them all out, that would be a total of 9 x's multiplying by each other. So that would be x to the 9th. So x cubed is being cubed to get x to the 9th. Okay, get rid of this. All right, let's see. To get y to the 6th, something times something times something.
2.
It needs to be 6y, so that's y squared. Y squared times itself would be a string of 6y's if you can visualize that. All right, done with that one. Let's do the other one. Something cubed gets me 125. That's 5. 5 times 5 is 25. 25 times your third 5 is 125. Okay, z to the 15th. I need to break it into 3 chunks because something times something times something equals z to the 15th. So that's got to be z to the 5th. If there were 3 of those, that would create 15 z's. Okay, I figured out a and b. In my opinion, I think that's the hardest part. And now I'm going to kind of skip down here because I need a lot of room. I'm going to set up my binomial times my trinomial. I need a lot of room here. Okay, in my binomial, I just put a and b. Okay, so a is all of this stuff, 4x cubed y squared. Okay, b is 5z to the 5th. Okay, coming back to my trinomial. First part of my trinomial is take a and square it, and I got to square all of it. Okay, so if I take a and square it, 4 squared is going to be 16. What if I take x cubed and square it, meaning x cubed times itself? How many x's are there?
6.
I see 6. 3 there, 3 there. That would be a string of 6. Okay, so that's, if I square x cubed, I get x to the 6th. If I square y squared, I'm going to have a total of 4 y's. All right, I've got to do the same thing for back here. Let's see. So in the back, I'm going to do b squared. So 5z to the 5th squared. 5 squared is 25. Z to the 5th squared. So z to the 5th times itself. If you can visualize, that'll be a total of 10 z's. So we okay? All right. My middle term, I do a times b. Okay. So 4 times 5 is 20. Piece of cake there. It's kind of an ugly 20. Let's erase that. There. All right, x cubed times, there's no other x over there. If there was something over there and I could do x cubed times, let's say x to the 5th, for example, that would be a total of 8 x's, but there's nothing to multiply this x cubed by, so I'm just going to leave it be x cubed. Okay, y squared, same thing, nothing to multiply by, so I got a y squared in here. Z to the 5th, nothing to multiply by, so I just need a z to the 5th in there. All right, last part, I'm going to do my signs. Okay, SOAP, same, opposite, always positive. So first sign, same as the problem. In this case, it's plus. Second sign, opposite of the problem, so that's minus. Third sign, always positive. And that big old beautiful thing is how you factor that example 2. It looks a lot more complicated than what it actually is.